So, I will be showing you another biasing circuit, and this is the emitter-stabilized bias. So, I have actually introduced this circuit in my previous lecture. Yeah? So, here, in this emitter-stabilized bias, we are going to determine the base current, the collector current, the VCE, VC, VB, and VE. Okay? So, ano ba ang configuration na ginamit dito sa emitter-stabilized bias? Okay? So, kung titignan natin yung overall na amplifier circuit with the AC in and AC out, okay? So, ang AC in natin or the voltage input is connected at the base, and the output voltage ay to be measured at the collector. Then this is a common emitter configuration. Now again, ang concern pa lang naman natin dito are the DC parameters. Then we are going to open na the capacitors, and this will actually remove the V in and the V out. Okay, so we are left with the DC circuit. Okay, so ilagay muna natin yung direction ng ating current. Okay, so IE is in this direction, following yung direction ng arrow sa symbol. Okay, so palabas siya. So therefore, ang IC mo dito is paloob. Okay, at ang IB natin is towards the right. Okay? So, voltage polarity plus, minus, okay? Plus, minus, plus, minus. Okay? So, we are, eto, ilagay ko na lang muna din yung voltage across the base emitter terminal. So, positive yan, negative dito. Now, we are ready to determine our KVL equation. Okay? Lagi, saan ka ba mag-i-start to establish your KVL equation? Dapat, dun ka lagi dun sa kung saan mo madadaanan yung VBE. Okay? So, mas madali kasing mas konti yung unknown. Parang ganon. So, KVL starting from the source down to the ground. So, KVL equation would be 20 minus, anong current dito? It will be IB. And that is, ang voltage now will be 510 kilo ohm multiplied by IB minus VBE, which is equal to 0.7, and then minus 1.5 kilo ohm IE, and that is equal to 0. Now, if we are going to look at our equation, KVL equation, there are actually two unknowns. We have the base current and the emitter current, but we can always express IE in terms of IB. So, remember our basic equation, IE or the emitter current is equal to the sum of the collector and the base. Okay? And likewise, from the beta formula, IC is equal to beta multiplied by IB, then this will actually result in an IE equal to beta IB, okay, plus IB, and factoring out IB, we have the emitter current is equal to IB multiplied by the quantity beta plus 1. Okay? So, we are going to substitute this now dun sa IE sa ating KVL equation kanina. Okay? So, substituting, we have 20 minus 510 kilo ohm IB minus 0.7 minus 1.5K multiplied by beta is 100. So, beta plus 1. So, 101 multiplied by IB. Then, this is equal to 0. And this will actually give us the equation to solve for IB now. And IB is equal to 20 less 0.7 all over 510 kilo ohm plus 1.5K multiplied by 101, and this will give us a base current equal to 29.18 microampere. Okay? Next, so we're finished with IB. Okay? Ang IC naman, so madali na lang. Gamitin na lang natin itong equation na to. So, solving for IC, we have 100 multiplied by 29.18 microampere, and this will give us 2.92 milliamp. Okay? So, ganun lang. Madali lang siya. Okay, so what's next? VCE. So, ang VCE is nasa output loop. Okay? VCE would be here, plus and minus. Then, what are we going to do? Kunin lang natin ulit yung KVL down this loop or down this path. Okay? So, solving for or determining yung KVL natin, it will be 20 minus 2.4 kilo ohm IC. Isa-substitute ko na yung value ng IC ha. So that is 2.92 milliamp. Okay? Minus, we have VCE. And then minus, okay, 1.5 kilo ohm multiplied by beta plus 1. So, 101 multiplied by 29.18 microamp. And this is equal to 0. So, kung titingnan natin, we only have one unknown, which is VCE. At kung isosolve natin tong equation na to, we will actually get an answer of 8.61 volt. Okay? So, we're done with this also. So, what's next? We are going to find the VC, VB, and VE. So, saan natin isosolve yung VC? Okay? Dito. VC is here. Okay, yan. VC. Yan. So, there are actually two ways to solve for VC. Pwedeng it will be 20 less the drop here, or pwede ring VC dito, it will be VCE plus VE. Okay? So, eto, i-ano ko na rin lang. So, eto yung VE natin. Okay? VE would be the voltage from the emitter to ground. So, VB naman, eto siya. From base to ground. Okay? So, let's start with VC. So, pwedeng dalawang ways to solve for VC. So, pwedeng 20, okay, yung whole voltage, okay, sa circuit natin, which is 20, minus the drop across the 2.4K. So, 2.4 kilo ohm voltage drop multiplied by the current 2.92 milliamp. Okay. So, this is equivalent to 13 volts. Okay. Pwede rin naman na VC. Okay, you try this ha. Isusulat ko lang kung paano i-solve. So, VCE plus VE. Pwede rin itong solution ng VC. Okay? So, next. So, what is next? VB. Okay. Again, there are two ways to solve for VB. It will be 20 less the voltage dito, or pwede rin naman na VB is equal to VBE plus VE. Okay? So, I think it would be more convenient if we are going to solve for VE muna kasi kakailanganin natin yan. So, let us solve for VE first. Ano ba yung VE? The voltage across the 1.5K. So, madali lang siya. Resistance multiplied by the current. So, resistance is 1.5 kilo ohm multiplied by yung current niya is 101. Okay? Ito yon. Yan. Beta plus 1 IB. So, 101 multiplied by 29.18 microamp. Yan. Microamp. So, VE now is equal to 4.39 volts. Okay? So, going back to the VB, how do we solve that? So, just like what I have said, there are two ways. Pwedeng 20 less 510K multiplied by IB, which is 29.18 microamp. Or, pwede rin naman na VB is equal to VBE plus VE. Okay? So, any of these two, dapat ang magkukuha nating value ng VB is equal to 5.12 volts. Okay? So, this is example number 1 for the emitter-stabilized bias circuit. Okay? So, I'd like you to study all the examples in chapter 4 of the Boylstad book and yun, practice, okay? Practice solving the end of the chapters problems dun sa libro. Okay?